Okay, so this is a recording of me doing the answers to Regents Review number 1. Alright, so in the first problem, we have a triangle, and it tells us that angle B is 62, which they already put in the problem. They ask us for the value of x that would make these two legs congruent. So we need to first remember that if two sides of a triangle are congruent, the angles across from them are going to be congruent. So we can do 180 minus 62, and that gives us 118. Now we take that 118 and divide it into two equal parts, which gives us 59. So that means angle A is 59, and angle BCA is also 59. So there's two ways we can get x. We can either use the fact that these two angles are a linear pair, so that means x would be equal to 180 minus that 59. So that brings us to 121. Or we can use an old property, which is that the sum of the two non-adjacent interior will equal the exterior. So that would mean that x is going to be equal to 62 plus 59, which also gives us that 121. Okay, the next one. We have another triangle. They tell us that BDC is 100, so we have to put that in the picture. From B to D to C is 100. Angle A is 50. And DBC, from D to B to C, is 30. So right away, we would know that angle C is going to be 180 minus that 100 and that 30, which means that angle C is 50. We also know that this angle right here is going to have to be 80 because these two together are a linear pair, which means this angle here is going to be 180 minus the 80 and minus the 50 from down here, which gives us 50. So this angle here is 50. And it asks us about these options here, which one is true. So first one says that ABD, triangle ABD, is obtuse. Let me just see, sorry, ABD. ABD is from here to here to here. Now it can't be obtuse because none of the angles are bigger than 90, so that one we know is wrong. It says that ABC is isosceles, so ABC would be the outside triangle. Now if something is isosceles, two sides have to be the same, therefore two angles would be the same. So we did figure out that this was 50, and we also figured out that that was 50, so this is actually true. Let's just double check that the other things are false. So from A to B to D was 80, which is not true. ABD was 50, so that's wrong. And then ABD is scalene. From A to B to D is scalene. That's also not true because these two are 50, which would mean that this side is equal to this side, so it would be isosceles, so that is also wrong, which means the answer is choice 2. Okay, number 3. Okay, number 3 is talking about a rhombus. So as soon as we see the word rhombus, we should know that in a rhombus, all four sides are congruent. So if they want the perimeter, we need to add all sides, which really we could just do 4 times the side since all of them are the same. Now to get the length of one side, you need the distance. It doesn't matter which pair of letters you choose because they're all going to give us the same distance. I prefer not to work with negatives, so I would use these two. Now I would use the distance formula, which is the square root of, in parentheses, x minus x, close it, square it, plus y minus y, close it, square it. So the distance between those 2 points would be 3 minus 2, close it, square it, and 0 minus 3, close it, square it. So now we have 3 minus 2, which is 1. 1 squared is 1. And 0 minus 3 is negative 3, but negative 3 squared is positive 9, which means the distance of one of the sides is 10. But don't forget, we need to multiply that by 4, which means we get choice 4 for radical 10. Okay, number 4. Okay, so number 4, we have triangle ADE and ABC. It's reflected and then dilated. So when we reflect, all the angles stay the same, and even when we dilate, all the angles will stay the same. Please remember that angles will never change size. So right off the bat, we could cross out choices 3 and 4 because that's saying that the angles are going to be half the size, which is not true. The question here is which angles are the congruent ones. So remember, I always like to look at the letters from the name of the triangles because I know that A corresponds to A, D corresponds to B, and E corresponds to, whoops, it should be triangle ABC. So E corresponds to C. So choice 1 says BAC, so it goes BAC. So 1, 2, 3. So that would correspond to DAE, which is not what choice 1 says. Okay, I'll use a different color to show us this relationship. So ABC, so ABC this way would be the same as ADE this way because that's the same order, which is exactly what choice 2 says. Okay, wanted which one was true, and that one would be true. Okay, number 5, the last one here. Gives you 2 points, so if you want to graph them, you can graph them. I'll make this a little bit bigger. I'll do it algebraically as well. Actually, I should say arithmetically because we don't use any letters, so it wouldn't be algebra. Okay, so we'll do it graphically first. So negative 1, 2, 3, 4, 5, 6, down 1, 2, 3, 4, 5. That would be right here. And I'll call that A. And then B is 1, 2, 3, 4, 0. So B is here. Okay, now you have to remember that if you break something down into a ratio of 2 to 3, that means there are 5 equal parts. So if you're going to use the line, sorry, it's not that straight with my iPad here, we need to break this change in Y into 5 equal parts. So this is going up 1, 2, 3, 4, 5, and this is going to the right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So instead of going up 5, we're going to divide 5 by 5 and get 1, and instead of going to the right 10, we're going to divide that by 5 and get 2. So we're going to go up 1, right 2, up 1, right 2, this is so sloppy, up 1, right 2, up 1, right 2, and up 1, right 2. So now we need to pick the point that's 2 segments to 3 segments. So here's 2 segments. And here are 3 segments. So that one point where the highlighter changes color would be the answer. So this is negative 2, negative 1, negative 2, negative 3, I think, because my graph is very sloppy. So I'm going to do this arithmetically. So I'm going to start with negative 6, negative 5. And then down here, I'm going to put 4, 0. I'm going to break this down. That's 1 segment, 2 segments, 3 segments, 4 segments, and then the 5th. So we always do bottom minus top. So 0 minus a negative 5. I don't know if this is going to move over. Well, 0 minus a negative 5. It's not going to let me write, so let me erase. So 0 minus negative 5. Super sloppy. And divide that by 5. So 0 minus negative 5 is 5. 5 divided by 5 is 1. So that would give me negative 4 if I add 1. That would give me negative 3 when I add 1. And negative 2 when I add 1. Negative 1 when I add 1. And 0. Over here we'll do 4 minus a negative 6. Divide that by 5. So I get 2. Negative 6 plus 2 is negative 4. Plus 2 is negative 2. Plus 2 is 0. Plus 2 is 2. And then plus 2 more is 4. So then again, we have 2 segments to 3 segments. So where the colors change would be the answer. So this guy right here corresponds to that point right there, which means P is negative 2, negative 3. You don't have to do it both ways. Either show the picture and explain how you got there, or show the arithmetic on the side. All right, that's it for Regents Review number 1.